Okay, so just as a recap, here is homework set 4, which is due Thursday. I already spoke about how to solve this first one. I think you've already seen enough to know how to do question 1. Question 2, it involves this sort of meta processing of the implicit function theorem, and that you need to know what to put into it. This is pretty obvious. I'm giving you an implicit function, x, y, and z are all here, and then I'm asking you in a very straightforward way to tell me what the explicit function, if it exists, and if it does exist, what's its derivative, partial derivative at this point. It's very clear to you, hopefully. In question 1, it's very clear as to what the implicit function is. Everything to the left side of this equation is f of x, y, and z. And that will help you, I think, solve 1a and 1b. Just because it's very clear what f is. Capital. When I say f, I mean, if you remember from my slides and from my previous lectures, I usually use capital F. I do it because the book I teach out of does. Capital F refers to this arbitrary implicit function of whatever variables are in the equation that defines the implicit function. Whatever those variables are in terms, you put them all on the left side of the equation, and you call that capital F. And so capital F of however many variables there are is equal to 0. It's sort of a standard form for an implicit function. And my point is, it's very obvious here. I've already written it for you that way. Whereas in the second question, it is not so obvious. And so it's going to be up to you. I'll help you. You're here in class. I'm willing to help. You only have 2 days to do this homework, so I'm going to help you. But not right now. The thing you may need help with is deciding what's the capital F. What's the capital F here, and what are the variables inside the capital F? Okay, and that you need to do some modeling interpretation, I think, to answer that question. So before we do that, I will help you with that, especially if you're interested. Let's look at some practice problems or more problems for this stuff. By the way, I do have some optional problems I've put on course documents. I'm wondering, some of them are from last year. Let's see. Does anybody want to see this extra problems, implicit functions and total derivatives? It's something I posted a year ago, but we can talk about now. Or maybe we'll do some, but not all of them. Let's take a look. I want this to be full screen. Probably a way to do that. Fit to page. No. Sorry. 2-page view. No, just 1 page was ideal. It's probably a key shortcut or something. Well, that's right. First, I should share with you. You can see what I'm seeing. Here are some problems from a lecture about this stuff from last year. Does anybody know how to quickly just make this web page thing full screen? F. One of the F buttons. Okay, well, you should be able to see it here. These are some questions where I ask you to just find dy dx. Let's do this first one. Here's an implicit function, x squared y squared minus log x plus y equals 0. Find dy dx. You might immediately look at this and say, wait a second, log isn't defined for any negative numbers, and this could be an issue here. And you'd be correct. So you can't really find dy dx for every possible y and x. No, instead you can only do it provided that you're in a neighborhood that is well defined. And that would be where x plus y is positive, somewhere in that neighborhood. But not only does x plus y have to be positive, it has to solve this equation. Which, you know what, I can already tell, because this term over here is positive. That means if I were to move log x plus y to the other side, that has to be positive. Yeah, so this isn't really part of the problem. I'm really just asking you to find dy dx, but I do think, of course, it's in a neighborhood of x and y that satisfies this equation, and x plus y has to be positive. Okay, provided that, let's do the problem. Somebody good enough at this stuff that they could just tell me how to start and how to do this? What would dy dx be? Actually, for all of these, this is 3 problems, but for all of them, it's going to be equal to, which one is it? Negative f partial with respect to what over what? Which one's on the top? X or y?
X.
It is x. Was that a guess or did you know?
I wrote it in my notes.
Great. Yeah, because we're looking for dy dx, and dx is here at the bottom of this derivative. That's why the x will be at the top of this formula. I'll just write it here. Let me write it a little bit more neatly. dy x equals negative, don't forget this negative sign, fx over fy, where you might say, well, what is this capital F? Capital F refers to this whole bunch of stuff on the left side of the equation. Okay, so let's do this first example here. What is dy dx? It's going to be equal to, we got the negative. What belongs in the top? Just take the partial derivative of the top with respect to x. Are you guys good at this? By now, you have a lot of practice. What's the derivative, partial derivative of this function with respect to x? Can you take the partial derivative of this with respect to x?
Is it just 2xy squared?
Yeah.
Minus 1 over x plus y.
Anything else?
Times 1, I guess.
Times 1, yeah, well, you don't need the times 1. You're correct. Yeah, that's good. Thank you, Kai.
Mm-hmm.
And then if we did it for y, it would be very similar. I won't make you say it because it's pretty much the same. They're almost equal to each other, but not quite. The only difference is here there's a y squared, not an x squared, but not on y. Okay, so that's actually the answer. That's how you do it. And then, of course, we could do it with all these other ones, which are more complicated. I don't have much space on my screen to do this second one, I think. Oops. Oh, yeah, that's weird. I scroll down and the words stay. Do you want to see any more? Do you want to see any other examples of this? By the way, I do have not just the problems, but the answers on this. I want some feedback from the class. Do you want to see the second one or the third one done, or you think you're good?
Yeah, I'd like to see more.
Which one? Both?
Yeah.
Second?
Both.
Second one? Okay, so the second one maybe is interesting because there's a z in there. It's not just x and y, there's a z. How would that change it? The answer is not that much. You still just treat z as a variable, I'm sorry, as a treat it like a constant. Why? Because when you see this notation here, f with the x subscript, that means partial derivative. Just FYI, this curly d f over curly d x. These two things mean the same thing. Okay, please don't get confused with the notation. It's just shorthand. So because it's partial here, that's what the curliness of this d refers to. When you see something like this and there's a z there and a y and whatever, just treat the y and the z as if they're constants when you're doing fx. So what would it be? Where should I write it? I'm wondering where will I have the most space. How about underneath? Actually, does anybody want to tell me what the answer is? Here, I'm just going to like write the answer. dy dx equals negative. That's that negative there, and we talked about that probably last class. It comes from algebraic manipulation of the total differential. That you bringing something from one side of the equation to the other, it becomes negative. That's just how algebra works. But that's where that negative comes from. Okay, dy dx is equal to, what would it be? Let's take the derivative. I'm sorry, the partial derivative of this equation with respect to x. What would I get?
Would it be 2xz over y plus 3?
Is that it? I'm writing it this way to save space. You're right. Is that, who said that? Amina?
Yeah, Amina.
Yeah, correct. Thank you. And this other part, you just, for now, just ignore it. 2xz over y plus 3. That's correct. That's what goes on the numerator. In the denominator, now we do this fy, partial derivative of f with respect to y. It's going to be a bit annoying here for this first part, but not so bad. What should you notice? Y is in the denominator. That's something raised to the -1 power. So there's going to be a -1 outside this expression. Let's just put it there. The numerator stays the same, x squared z. There's no y's in it. I'm sorry, this is a little sloppy. Divided by, what goes in the denominator? Well, it was y plus 3. When you take the derivative of something, you raise it to the power 1 less than it previously was. You reduce the exponent by 1, so -1 becomes -2. And so y plus 3 becomes y plus 3 to the -1st power becomes y plus 3 to the -2nd power. That's why I can put it here in the denominator square. This is a fraction, by the way. Hopefully you can tell. So that's the derivative of this first term with respect to y. What's the derivative of the second term with respect to y? Well, we have something raised to the 1/2 power. Once again, let's bring the exponent out. That's a 1/2 times the thing, zy plus 1. I'm just treating z like any old constant, y plus 1. But now instead of raised to the 1/2 power, you need to raise it to the -1/2 power, because that's 1/2 minus 1. I'm going to just take the easy road here and put the negative in the exponent. What I've written here is correct, is a good answer. You don't have to simplify it if you don't want to. I mean, some people don't like negative exponents to be left.
Professor?
But did I make a mistake? Yeah.
Why wouldn't you take the derivative of the inside?
Oh gosh. So there should be a times z.
Yeah.
Thank you. Yep. Times z. Thank you. Right. That's the chain rule. I wasn't done. I was testing you and you passed the test. Yeah. Because the derivative of the inside zy plus 1 is z. That's where that z comes from. Thanks, Jonathan.
Also, why is the y plus 3 squared and not just the y?
Good question. Because when you have a fraction, it is against the law to break up the fraction and say, I'm going to take this part separately than this part. That is not an algebra. That is what I call malgebra, from the Latin mal, which means bad. It's a bad joke that I heard once. you need to treat this entire denominator as its own single unbreakable term, and therefore it is this y plus, can I just undo that squiggle? Yes, it is this y plus 3, which is being raised to the -1 power. In fact, I'm taking the derivative of y plus 3 in some sense and multiplying it by the whole thing. It just happens to be 1. It disappeared. Whereas, as Jonathan said here, I was taking the derivative of zy plus 1, and I need to multiply it. And here it was a z. It mattered. Here it was just a 1, and it didn't matter. But the answer to your question is, anytime you have something in the denominator, you have to treat it as its own whole object. Or I guess the word is term. You know, this has to be considered one term in the denominator, and you need the whole thing squared.
Okay, yeah, I got it. Thank you.
So I think now this is correct. I can cheat and look ahead. Yeah, here are the answers. Yeah, that looks good. Sorry, this is crazy. Is it okay if I delete? I'm gonna clear my drawings. That's better. Oops. And look down this way. Did you want me to do the third one, or are we good? Here's the answer to the third, right? You're gonna take x becomes alpha x to the alpha minus 1. That's that. Minus y over 1 minus alpha y to the minus alpha minus x. That's what it's right here. That's dy dx. Okay, I also had this total derivative example, which, so I explained total derivatives. It was part of the lecture material before the midterm, but I think we're still going to use it after the midterm, and there's maybe something where you're kind of using both implicit functions and total derivatives together. I have an example of that I want to give today. So you tell me, does anybody want to see this problem done? This is a total derivative example where here's a firm's profit. It's equal to this complicated function of both Q and P, where Q is a function of P. Okay, so P is price of refined oil. I'm sorry, P is the price of crude oil. Q is the price of refined oil, which is itself the function of crude oil. So, if, you know, imagine you're a firm who's producing this good refined oil, and you care about the profit that you make making this refined oil, but it depends on the price of crude oil. So your input and your output are very closely related. And here, you know, this function just is a way to describe profit. And what's the question? Find the derivative of profit with respect to P. If you wanted to know something like, how does my profit change as the price of crude oil changes? You know, what's the best possible, how does my bottom line change if crude oil price changes? The answer would be d pi dq, I'm sorry, d pi dp. And you would need a total derivative to solve that. Does anybody want to see that example being done? You know, if nothing else, let me say how I would do it. I would attack this problem just directly going d pi d p and say anything that is related to p we need to do. There's this indirect channel from P onto Q, and then there's a direct channel from P. And you actually have to do those separately, I have to say. That's what the total derivative is. It's the way to delineate all of the effects of P on pi, both directly and indirect. I think I could do that real quick if you guys have any interest. Let's write it out here. d pi dp. What? Didn't do it. Okay. It's equal to, okay, so it's gonna, we're gonna have the two channels, indirect and direct. Let's do the, which one? Let's do the indirect first, which, as a reminder, is going to be, it's going to be d curly d pi dq times dq dp. Right. This is that part of the total derivative that comes from the first channel, indirect channel. So if we're going to write this out, let's do parentheses here, make it more clear. Let's see, d pi dp is going to be, I'm sorry, q. So we're treating q now as the variable. This whole thing was raised to the 1/2 power. In fact, now it'll be raised to the negative 1/2 power. So let's write 1/2. That whole thing, 10 plus 4q. I'm not going to bother with the thing. You should know that that's there. To the negative 1/2 power times the derivative of this with respect to what? With respect to q. And that is 4 times 4. Okay, that's from this first term. I think I'm done. I didn't forget the chain rule part this time. But now the second term, there's a minus, so let's have that minus. Remember, we're doing it with respect to q now, and yes, there's a p here, but don't ignore that p. But you know, we're so I guess it's part of what I'm saying is here. You know, how do you know when to do it again? Like, oh wait, q and p. That's why it's a partial derivative. The partial derivative says right now I'm just looking at the isolated effect of q. Don't worry that it's also a function. And it should just be p squared over 10, right? This second term, the derivative of p squared q over 10 is just p squared over 10, right? Because this is a partial derivative. This whole thing was this term, the d pi dq term. Now I need to multiply that by dq dp. I haven't told you what dq dp is, so you just leave it. Just leave it as dq dp. In other words, you can't solve this problem down to a numerical value because I haven't given you the formula for p. The q is a function of p. I haven't told you what that is. If I did, then perhaps you could solve this. Even then, it would still be a function of p because I haven't told you what p is. But that doesn't matter. Like when you see a problem, it asks you to find the derivative. This, you know, that's what you're looking for. Find the derivative of profit with respect to p. It's not asking you to find a numerical value. I will tell you if it is. What it is asking you to do is solve the problem in terms of the fundamentals, the variables that are defined in the problem, which is p and q, and perhaps dq dp. That would be a good answer to this problem. Okay. You see where this first term comes from? That was the direct channel. We now need to think about the indirect. I'm sorry, that was indirect. Now the direct would be d pi dp. And we can do that as what? We have to do this thing again because there's a p in here. But you ignore this. Don't. When I say ignore, I mean don't worry that q is a function of p. Right now we're taking the partial derivative, so you just treat q as a constant. Let's do it. You get 1/2 this whole thing plus 4q minus p raised to the not 1/2 power, but negative 1/2 power, because 1/2 minus 1 is negative 1/2. Now, because of the chain rule, it's not a times 4, it's a times negative 1, right? You guys see why here it's a times negative 1 instead of here, which was a times 4. So you get a times negative 1. You're not done. That was just the first term. I think you're done with the first term, but now the second term becomes, let's leave it, negative 2pq over 10. Sorry if not every term here is as legible as I would like, but that's it. That should be the answer. And it's this is a total derivative problem applied to this. This is an economic situation, a firm where there's two prices that really affect its profit, the prices of inputs and outputs, and they're related by some function, which is Q of P, which I haven't told you what Q of P is. But if I did tell you what Q and P is, you could take the derivative of it, plug it in here. If I told you what P and Q both were, you could plug them in each of these places. And in fact, you could get a numerical value here, but I'm not asking you in this part. You guys have any questions?
I have one question for the first term.
Yeah.
The p squared over 10. Why did the q go away? Like completely?
Oh yeah, because I'm taking the derivative with respect to Q. So this is something which is linear in Q. It's like Q to the first power. That goes away. Like if I said, what's a derivative of 3Q with respect to Q? You would say 3, right? Because 3 is the coefficient of that linear term, linear function. Same thing here. So Q is the variable. This whole term is linear in Q. Would you agree? Do you know what I'm saying?
Yeah, sorry. Someone just walked in, so I got distracted. Yeah, I did. I was confused because, like, for the term before, like, the 4QP is just 4Q.
So for this one, it's not linear. This whole thing is not linear in Q.
Oh, okay.
This is something which is like Q raised to the 1/2 power. That's why we need all this business in here.
Okay.
Whereas this term is something Q raised to the first power, which is so easy. When you get something raised to the first power, it's linear. The derivative is just whatever the constant coefficient is.
Okay.
That's why that
Okay.
you're right to say, wow, this one has all these complicated parts. This one looks a lot simpler. It's because of the power that you're raising Q to.
All right.
Sure.
Thank you.
No problem. Okay, so I think that hopefully helps with these types of problems. You can see the actual answer was down here. Looks like the same answer. Oh, I can almost exactly overlay it with what I did here. Oh, here I took the 1/2 and the 4, and they get multiplied by. Okay, that just, I'm sure that looks awful. I don't want you to have to see that. Clear, all drawings. Okay, so those are those that are available for you also on Blackboard. I wanted to stop sharing. Continue on with. Just a little bit more on implicit functions before we go on and talk about the homework. I thought I had it open already, but I'm going to Blackboard, just so you know. This is exactly where I'm getting it. It's from course documents, implicit functions. It's a PowerPoint slide. I have updated it. If you've looked at this recently, it's been updated. Okay. This is in fact the question I ended the last class on. So let's talk about that. Share screen. Here we go. Share. Once again, barely visible. Okay. Right. Current slide. Boo, it's not doing it. Slideshow. Current slide. Now it should. We good? This was a question from last class. Can we find an explicit function zxy in a neighborhood of 1, 1? Yes, we can. Although let's answer this. You guys are gonna get sick of these problems. Maybe I'm doing too many. Apologize. All right, so how do I answer question 1? I want to take a look at f of z right now, right? Do I have enough room to write it up here? Let's try to write f of z. By the way, f, of course, is, hopefully you're familiar with this notation. You're comfortable that capital F refers to this whole left side of the equation. What is the partial derivative of that with respect to z? Well, of course, it is x squared y, correct? And what else? Plus 3x. See that? Plus 3x. Now the question is, what happens at 1, 1, 1? Okay, at 1, 1, 1, it becomes, I just need to plug in 1 for all of these. 1 times 1 times 1 equals 1, plus 3 times 1, that's 4. So f of z is equal to 4, which is not equal to 0. Therefore, we can find an explicit function, zxy in a neighborhood 1, 1, 1. See how we answered this question? We're good. Let me know if you have any questions. Okay, now how do I answer this? What's the partial derivative dz dx? What should it be equal to? Somebody tell me. Otherwise, I'm just kind of doing this for myself. I'm wondering.
Negative f of x over f of z.
Correct. Thank you. Negative f of x over f of z, which, hey, we already found f of z. It's 4. So let's just find f of x. F of x, I keep saying f of x. That is poor speaking mathematically. I could say f sub x maybe, but it's the partial derivative of f with respect to x. That's equal to 2x y z plus, from this term we have a 3z. That's it. All over f of z, which, hey, I already calculated is 4. I'm just going to put 4 there. Why not? Oh, I forgot the negative. Don't do that. Don't just like write the negative here, but then not on this side. That would be bad. Oops, I didn't leave myself enough room for a negative, but that should be a negative sign. You know what I can do? Here's a nice little thing. I can just put the negative there. Doesn't matter where I put the negative. I have more room in the denominator, so that's where I will put it in the denominator. Okay. Now I just plug in 1, 1, 1. Right? Look, I'm only asking you at this point, 1, 1, 1. So that means x equals 1, y equals 1, z equals 1. Just plug those in. 2 times 1 times 1 times 1 is 2. Plus 3 times 1 is 3. So 2 plus 3 is 5. The answer, hopefully you will see, is negative 5/4. Okay? We get that from the use of the implicit function theorem corollary, which is how we got this. And then plugged it all in. I think this is notable because you haven't actually found, although you could. This would be one where it's pretty easy to solve for z, wouldn't it? See? Let's say you've never heard of the implicit function theorem corollary, but you do know what a partial derivative is. And somebody asked you this question: find the partial derivative dz dx. You could do it. You would try to turn this into an explicit function by moving all of these terms to the other side and then dividing by x squared y. You would get this big fraction. So what? And then dz dx, you would take the derivative of that fraction with respect to x. You may have to use the quotient rule. Okay, you would use the quotient rule. You would get an answer. You would plug in x equals 1 and y equals 1. You don't have to worry about z, but you should get the same answer, negative 5/4. 2 ways to get the same answer, and that's fine. The point, though, of me teaching you this is that there will be some times where you just can't solve for z. This is an easy one to solve for z, but but if it might be literally impossible to solve for z, at least using algebraic methods. You could do it computationally, maybe, that's sort of cheating. So, any other questions about this?
I had a question.
Sure.
I think I missed it for question 1, the explicit function part. So you find the partial derivative of z and then you plug in 1. But why isn't there there is an explicit function?
Yes. Can we find an explicit function zx in the neighborhood y? Yes. Here's my answer. B/c means because f z is not equal to, that's a not equal to 0.
Oh, okay.
So that's how you want it. I do ask you a question like this in your homework. So hint, this is how I want you to answer it. If the answer is yes, can we find an explicit function in this neighborhood 1, 1, 1? Yes, because at that point, fz is not equal to 0. We found it, it's 4. And since 4 is not 0, the answer is yes. Remember the unit circle? The unit circle said, oh, we can, we're good at the top of the circle because passes the vertical line test, but at the rightmost point of the unit circle, there is no neighborhood of that rightmost point where I can draw a line in that, and it only goes through one of the points in the neighborhood. It actually will always go through 2, no matter how close you get to that point. This will always be true. So that's what that's one way to intuitively understand what's happening here with why fz has to not be equal to 0.
Okay, I see. That makes sense. Thank you.
Sure. All right, I got one more, I think, rather complicated one, which I think will help you with the homework. Okay. This is a mess, but it does tell you that the answer is, am I using annotate too much? I apologize. All right, this is what we did. We got -5/4. And by the way, you can see these. You can always go back and see these on Blackboard. These are posted. And here's my note that I just want to use. I say that, but on the homeworks, I'll be. You'll see on the homework I gave you something with a lot of variables. A lot of it has C, Y, C, S, I, T. That's 5 variables plus an exogenous variable G, 0. But still, when you're using this F, it's not so crazy, right? It'll be roughly 2 or 3 variables. You just have to decide which of the 2 or 3 variables you're including. Okay, here's a more complicated problem. And it's written in words too, which makes it even harder. I think most of you are econ majors, if not all of you. You're econ majors and you have some idea of profit calculations, even if I didn't give you the formula for profit, but you should know what it is. If not, I'm telling you right now. Profit is equal to revenue minus cost. And revenue is equal to price times quantity. This is the simplified theory of the firm version of profit. Profit equals price times quantity minus cost. Sometimes cost will be split up to, cost could be split up into like average cost times quantity. Of course, that's definite, by definition, that's true. There are other ways to break up the formula for cost, but in general, you might just see C for a cost function. Okay, in this example, we have a monopoly that's regulated, and so it doesn't get to just make whatever profit it wants. It's allowed to, and therefore, let's assume it's required to make a profit of alpha. It wants to make this profit of alpha. It'll make exactly alpha profit because it can, and it won't make any more than alpha. So I don't just have quantity, I actually have the quality of the good also as perhaps a choice that the monopolist could make. And in fact, maybe even the regulator needs to think about this too. If I'm trying to decide what alpha should be, I might think about what effect that has on X. So this is like number 2. Like I'm thinking ahead as a regulator. This is some intuition for the problem, which actually is not needed to solve it, but just for fun, for you guys to think that you're doing something relevant to economics. Why not just think that, you know, ideally you use the math tools from this class to work on other math problems, econ related problems. So in this problem, alpha is a variable, but it doesn't depend on x. It's determined exogenously by some regulator. Okay, Q of x is the firm's optimal quantity. If there's more than one way to produce, to get this alpha of x, this profit of alpha, Q is the optimal one. Q is a function of x because the quality of the good constrains in some way how much quantity you can make. That's assumption here. That Q, the way that you would optimally produce a quantity depends on what quality X you're choosing. I couldn't use Q for both variables because that's just bad. So Q is a function of X. Quantity is a function of X. P is price. Price is a function of X. In other words, what I can sell them for on the market, the price that people are willing to pay for these for this good, depends on X, the quality. And of course, the cost of producing the good will depend on how many, Q is the quantity, how much of this good you're producing, which of course is a function of X, and X itself, the quality. So the quantity and the quality both are factors in what the cost of producing this good is. So this is kind of a, really have told you very little about this firm and what it faces. And once again, I want us to kind of be okay with that. I don't need to know exactly the numbers involved. I'm okay with just working with these functions. Q of X is a function. P of X is a function. C is a function of both Q and X, where Q is also a function of X. Okay, those are the fundamentals of the problem. Now what I'm asking you, in terms of these functions and their derivatives, find the following dq dp. You guys have any way of thinking about this before I just do it? Let's try to do it together. How would I sort of attack this problem in your minds? Let's do number one first. dq dp. I see Q and I see P.
Is it equal to the partial derivative of like P over the partial derivative of Q?
I don't think I understand what you're saying. If you do you want to say it again, or do you want to
It was just a guess. I don't
give
really
up?
know.
Okay, sorry. That's all right. Anybody else?
Okay.
I think what we need is, it's this meta problem of how do I come up with the implicit function I need to solve this? You're going to use the implicit function theorem here. Or these, you don't have to, but I think you should. It's already 121. Okay, go to 145. I think I have enough time. Anybody have an idea? We need to use this first sentence and essentially need to write that as an equation. Okay, this first sentence should be written as an equation, which will formulate in some way the implicit function of P and Q that we need to solve this first problem. You can't solve dq dp without some relationship between Q and P. If you had an explicit relationship, Q equals something that only has P's in it, Q equals some function of P, then it would be really easy. You just take the derivative. You're not going to get that, but you will be able to write an implicit function with both a Q and a P in it, and that should help you get this answer. So let's do it. In fact, hopefully you don't mind. I'm going to do more annotating. I'm going to write above this sentence a way to write it mathematically. Remember, this is what mathematical modeling is. It's just assigning numerical values, quantities to these concepts and establishing the relationships between them using equations. But that's what we need to do. Anybody want to say, or should I just tell you? Anyone feel like tell me how to write this first sentence? If the answer is no, I'll just do it. Sounds like the answer is no. Nobody's interested. Do not want to do it. Why should they? I'm the instructor. I should have to do it. Okay, I will. Let's first say what the profit of the firm is. I told you the profit of the firm, it is revenue minus cost. Revenue is price times quantity. So let's write that. Price, I'll even write a little X here, times quantity. That's the revenue of the firm, monopoly, right? Price times quantity is your revenue. Minus cost, this function, C of Q X, comma, X. And equals what? That's your profit. Have your profit written right here. It's alpha. Okay, so this is like it's not even a formula. It's more like an equilibrium relationship of this model that we're going to say P and Q are chosen such that this equation is true because it's a monopoly and it's allowed to make a profit of alpha. The reason I did it this way is because we're not yet ready to talk about maybe a profit maximization being part of the model. But you could imagine that the model doesn't just tell you these relationships, it tells you, and here are these incentives of the people inside the model, and a firm's goal is to maximize profit. So in other words, it's like a constraint on the variables because you have to assume it's always maximizing profit. Here, it's not so much about maximizing profit, it's just obtaining a profit exactly equal to alpha. Okay, so that's what this equation comes from. Now, do you have any idea how to do one? Anybody have any guesses? What do you think? I'd love a guess. Even if it's wrong, I'm still be very happy that you were willing to venture a guess. How about, I'll give you a hint. How about if we move this alpha to one side? This might look better. Instead of equals alpha, we'll say minus alpha equals 0. How about that? Does that spark your ideas for what to do? I'm going to run out of time. If I keep waiting for you guys, I'm going to run out of time. I'm going to just have to tell you. Although offer stands, anybody at any time, please give me some, even if it's just guesses, what if you do this? Okay. Some of you may be thinking, I can't do the normal, what would you like to do here? What would you like to do using the IFT? Isn't it this? P, remember, I'm switching, and in Q. This is just the description of the implicit function theorem corollary, right? What's F? What's F? Well, how about this? I just wrote it for you. I mean, what else is there on the screen? That's F. Okay, what about the X's? How do you guys feel about those X's? Can I take FP given all of these X's?
Yeah, would it just turn to 1?
What do you mean it would turn to 1? Thank you
if
for
you're
saying something though, Kai.
taking-
But by the way, thank you for saying something. But I'm just curious, what do you mean it would turn to 1?
F of P, like taking F of P, would it just...
F of P would turn to 1?
Well, no, taking F of P would just turn it to 1 times q of x, maybe? I don't
Yeah,
know
I
about
think you're
that.
right. I still don't get what you mean turn to 1. You mean the
Like-
p would turn turn
Like
to 1?
p of x would turn to 1, yeah.
Oh, okay. Oh, okay. You're actually taking the derivative now. I was asking a different question though. I'm asking, is it a problem that this p is itself a function of x? Sort of a yes or no question. Should I treat it as something differently than I normally would if those x's weren't there?
No.
I think you're right. That we sort of don't need to in this case. Why? Because when we write our capital F's, we get to choose what the variables are. We could say this is a capital F as a function of P and Q. And what about the x's? Well, yes, it is true that P is a function of x, but we're sort of not dealing with that right now. Why? Because look at what's in the denominator here. It's not even the denominator. It's just we're taking it with respect to P in some sense. So unless there's something that's going on in between P and Q that involves x, we can sort of ignore the x's here. I don't know if that makes sense. Am I doing too much hand waving? The idea is, yes, P is a function of x, but that doesn't matter for this question here. Let's do it. What would the answer be? You know, I think Kai was actually solving it and saying, when she said goes to 1, it equals 1, she just means the answer is Q here. I'm even going to drop the of x and just put a Q in the top. By the way, this negative here, I kind of want to stick that there. Negative Q for safe space. Oh, I think that's fine. I think that's all you need for the numerator here. What about the denominator?
The denominator would just be p and minus
Somebody help
I
her.
don't know. Yeah.
She's right so far. P, this first part becomes a P. The second part becomes what? Let me help her. No one's helping. No one's listening. We're on our own. Me and Kai are the only ones listening and trying to solve this. Okay, Kai, it's just you and me. How about this? The partial derivative of C with respect to Q. That's a good way to write this. Think of your total derivatives, right? Something like that. This lowercase c sub q, that's what that means. The partial derivative of C with respect to Q, but I need to multiply it by the derivative of Q with respect to X. So that actually is going to be here, Q prime. Yes, let's see. Well, okay, so yeah, so even though P is changing here, I said to ignore the X in this part, it still, I think it's possible Q is a function of X. And I think if I want to talk about the derivative of C with respect to Q, you know, so I could just stop here and say minus C Q, but because in theory it is possible that Q is changing with respect to X, you should multiply it by Q prime, which for me refers to, by the way, primes in this class refer to derivatives in the case where a function only has one variable. Okay, whereas Subscripts refer to partial derivatives in the case where a function has more than one variable. So hopefully this is not a deal breaker and confusing in the way that notation is used in this class. If I see a prime, it means it's because it's a function of one variable. And when you see a subscript like this or this, it means it's one of the partial derivatives of the function. But actually, I think you can stop here. Negative q over p minus cq times q prime. It is this. In terms of the functions given in their derivatives, that's what this is, the functions given in their derivatives. It's an answer to number one. You had to sort of think about what is the implicit function and what belongs inside. Sorry, I'm really wondering if I needed this q prime. I feel like it depends on some assumptions inside the model, but I would leave it there. And it's like you're taking the total derivative. It's the partial derivative, but then it's the chain rule. Is where that q prime comes from. Essentially, you could have it on all of these. But for now, I hope you don't mind it if we just leave that and say, yes, we did use the implicit function theorem corollary on this particular implicit function. And we're going to have to do the same kind of thing here for dx dA. Only now it's kind of like we're changing the implicit functions inside it. It should still be negative f alpha over f of x. Let's see what this is equal to. I think the alpha should be easy, right? That one's very easy. It is just 1. It was -1, but then there's a negative here. Let's cancel out those negatives and make it. Maybe I'll put this plus here to indicate that there was a negative that became a positive. Here's the negative outside. F alpha is -1. That becomes +1 at the top. Okay, so now this is the more economically interesting calculation. This is saying, how does the quality change as I allow the firm to obtain more profit? You may even want to care about this, as a policymaker. Am I doing some harm by restricting the profit to alpha, or what can I do about it? So now what we need is the partial derivative. This is maybe something you're more familiar with here, is how to find the partial derivative of this whole thing with respect to x, because it's written in a way where you can see all the x's very clearly, right? Does it matter that this could be a function of p and q, maybe? And x and alpha and c? I just don't want you to think that these sorts of problems can only come in the form where it's very clearly delineated what the implicit function is a function of. Whereas in reality, I think you might expect more situations like this where it isn't clear, and you need some flexibility in terms of when I'm taking this derivative f subscript x, how should I interpret all these variables p, q, c? Well, just treat them like functions now. Now you're not going to treat p as a variable like you kind of were here. Because this is the derivative with respect to p, you treated p as a variable, right? Here, I'm taking the derivative with respect to alpha. X is the variable of interest, the thing is saying, how does x change? Treat p and q and c as functions. Treat them like functions. You don't know the function exactly. You don't know the functional form, but you do. You can answer in terms of the function. Hopefully this makes sense. You can answer this by leaving it in terms of these functions. In fact, I think it'll be faster and easier for me to write if I don't even put the of x here. I'm not even going to write q of x, even though it's implied in everything I write. And in fact, maybe somebody listening could help me with what belongs here in the denominator. To answer this question number 2, what is dx d alpha? What belongs here in the denominator? Take the derivative of this with respect to x, partial derivative, but partial with respect to what? What's the other thing? Well, alpha is another thing, right? We're not saying how this changes with respect to alpha. That's what we did in the numerator. For now, we're only seeing what happens to this as x changes. So what should it be? Is somebody willing to tell me? Somebody give me this little bit of assistance in this lecture. What is the partial derivative of this with respect to x? Nobody knows? Ooh. I've done a bad job teaching you partial derivatives. I thought you understood partial derivatives and I was wrong. Here's the function, right? F equals px times qx minus c of q of x and x minus alpha. What's the partial derivative of that with respect to x?
Does it just change to p or just 1?
Would it change to p? No. Would it be just 1? No. I mean, thank you for answering. I don't think you can do sort of like ignore it, pretend it's 1, something like that here, because actually they both are functions of x.
Or are you going to write it like a subscript?
Write it like a subscript.
I don't know. I'm confused.
Okay. Well, I think you're maybe overthinking it, because if I just gave you this function and said, take the derivative of it with respect to x, I think you could do it. If you weren't even thinking of it in terms of this problem, if it was just a partial derivative problem and a total derivative problem, it's sort of, you need to use total derivatives because of this part, and you need to just use partial derivatives because everything else. You use the product rule. Doesn't that make sense? Here's a function of x times another function of x. I want to take the derivative of it. Just use the product rule of differentiation. Does that make sense? I guess maybe I don't understand why it doesn't make sense to everybody. I just want you to tell me let's do this term by term. Here's one term, here's another term, here's another term. Luckily, that third term will go away. But just first term, the derivative of px times qx with respect to x, you simply just use the product rule here. If you treat p and q as functions, then it would be the derivative of one times the other plus the first times the derivative of the second. So let's write that here. I'm going to just abbreviate it with primes. P prime q plus p q prime. Is this really confusing? How I get p prime q plus pq prime from this? I'm just asking you how to take the derivative of this with respect to x, and it's two functions multiplied together. That's the product rule. You should use the product rule. It's okay if you guys forgot, but that's my job as the instructor, is to remind you. Whenever you see two functions multiplied together and you're taking the derivative with respect to the inputs of those functions, you should use the product rule. Okay? Do you guys have any questions about that?
No, that makes actually sense.
Yeah, that's how I get p prime q plus pq prime. I took the derivative of this first term with respect to x.
Yeah.
So now let's take the second derivative of the second term with respect to x. Well, Now I need to use the total derivative. So I wanted a problem where you had to use both the IFT and total derivatives. So this is an example of that. To take the derivative of this with respect to x, I'm going to have to do it first term and then second term. The derivative of this first term is CQ subscript. Remember, that's shorthand for the partial derivative of C with respect to Q, right? Times Q prime, where Q prime is the derivative of Q with respect to X. I'm doing like a total derivative on this first part. And that's the first term of the total derivative, the indirect channel of X affecting Q. Sorry, X affecting C. That's what you get. C sub Q times Q prime. Now I have to do the direct effect too, which would just be minus C X. And that's it, we're done. Because the negative alpha, of course, doesn't exist down here. But I'm not sure if everyone is like really just totally confused or lost, or if they're not interested in this problem. But I think the only difference of this problem from all the previous ones is it's written in a way where something like P, you could think of it as a variable or a function. And in this first one, you need to think of P as a variable. And that's fine. P is a variable. But in the second one, where you have X is here, you need to think of P as a function. P as a function of X is what's happening. Because certainly X is something which exists as an input to this function. So that's why you have to use the product rule. That's why you need to use the total derivative to get this what belongs here, f of x, f sub x.
Yeah, I think I was just confused because we weren't doing the product rule when it was just a partial derivative, but makes sense now that they're
So I mean,
X.
the truth is you only have to use the product rule when you have two things multiplied by each other that are both functions, right?
Yeah.
And that's what's happening here. P is a function of X, Q is a function of X. They're being multiplied. You have to use the product rule and you get this. But see how I've answered the question in terms of the functions given. That's Q, P, and C are the three functions given. There's a Q, P, and C down here. And their derivatives, that's P prime, Q prime, C sub Q, C sub X. Those are their derivatives. I've answered at least what I can for this problem in the way that it's asked, is to say, don't give me numbers. You can't give me exact numbers, but you can give me these formulas using what you know about these relationships. It really comes from this first sentence. It's allowed to make a profit of A. You had to write that as a formula. And you know what? In the homework, I'm not asking you to come up with these formulas. I'm just telling you. But you will see. Let's go to the homework now, because dang it, it's 1:46. Okay, I'm going to quickly go to the homework and try to help you with what we can take from this problem and apply it to the homework problem. Okay. If you don't have time and you got to go, I understand. I will just do this real quick. Where's the homework? Here it is. Okay. Oops. Sorry, I need to share homework. Here we go. So it's a national income problem where there are these two equations. You might say, well, that's not enough to solve it. If there's 5 endogenous variables, it's not enough to solve it. Okay, you need to think of this as there is a function cy, iy, sy, ty. Those are all functions out there, even though I'm not being told what they are. They exist. Okay. Iy is some function out there. I'm not telling you what it is, but it's there. I am telling you that C prime, I prime, S prime, and T prime those are the derivatives of those functions, and they all exist. And each derivative is positive, in fact. It's positive. And furthermore, there's this assumption s prime plus t prime is greater than I prime. So we know something about this model. In A, I'm asking you to eliminate C from the model and write out the equilibrium condition. I think you should be able to do that. Just substitute in, you can eliminate C of Y by substitution. And you should get one equation here, and you can simplify that equation as much as you can. That will be the equilibrium condition. So, but at that point, you can change the Y's to Y stars, because after you've substituted in, you're thinking, what is the Y that would solve these two equations? And you call that Y star. Use the implicit function theorem to show that Y star G0 exists. Okay, so just like in our problem we just did, you think about what is the implicit function that is needed for this. Once you find that, you need to find that the derivative with respect to Y star of that is not 0. That's what you're going to use for B. And then for C, now use the implicit function theorem corollary using that new function that you've created. And so once again, you can sort of treat these as functions now. C and S and I, treat them all like functions. Just like we had with X. Remember how we had X? I know you were looking at dx something. That would be the equivalent of Y star. In this problem, Y star is like the equivalent of X. But you can still do this. You can still use the implicit function theorem to solve dy star dg0 and determine its sign. By that, I mean, is it positive or negative? You can use the information I've given you here to tell whether it's positive or negative. Okay, anybody have any questions about what I'm expecting you to do here for this homework? Please give it a shot. And I'm asking you to turn it in on Thursday. If you get really stuck, ask me about it and I'll try to help. But the due date is still Thursday. Do you guys have any questions? I should close this Zoom meeting so I can start the next one. You guys have any questions?
No, I don't have any.
Yeah, think of Y star here kind of like the X in the previous one. Okay.
Okay.
Okay. And G0, think of that like the alpha. All right, guys, I will see you Thursday.